All right, welcome back. So today we are going to be talking about absolute value equations and how to solve absolute value equations. Let's just take a quick minute to remember what an absolute value is. So if I were to ask you to find the absolute value of 6, let me draw these lines a bit longer for you. That way you can clearly tell the absolute value of 6. What we're trying to figure out is how many units away is whatever is inside that absolute value from 0. So we want to figure out if we had a number line and we were at 0, we had 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. We want to figure out how far away from 0 is whatever is inside that absolute value symbol. So if we're talking right here, how far from 0 is whatever is inside? Well, if we're talking about 6, well, let's count how many units. We have 1, 2, 3, 4, 5, and 6. So we have the absolute value of 6 is 6 because that value is 6 units away from 0. And that's what we're going to be looking at is whatever is inside of those absolute value symbols, how far away is it from so-and-so, right? So if we were trying to figure out the absolute value of 6, well, we know it's 6. The absolute value of negative 6 is also 6 because negative 6 is 6 units away from 0, right? So that hopefully should be a quick refresher about absolute value and what it stands to be an absolute value statement. So when it comes to equations, though, there are 3 steps in solving an absolute value equation. First, we use inverse operations to isolate the absolute value expression. This is the key here. We want to isolate the absolute value expression. Then we're going to rewrite the equation as 2 cases that do not involve absolute values. And finally, we're going to solve these new equations. The key here again is we need to isolate the absolute value expression because we want to be able to solve for the absolute value. We have to get all that isolated, just like we would a normal variable. If we were trying to solve for x in an equation, well, we would try to isolate the x to figure out what it's equal to. Well, here we're trying to find the absolute value of something and what that is equal to. So we have to isolate the absolute value symbols. So let's go through an example together. Let's say we want to solve the absolute value of x minus 3 plus 4 is equal to 8. Again, we want to isolate the absolute value of expression. So I notice that my absolute value expression is x minus 3 within that absolute value symbols. So the first thing we have to do is we need to subtract 4 on both sides. Now we have the absolute value of x minus 3, and that's isolated on the left-hand side. And we know that's equal to 4. So what we need to figure out is how x minus 3, that has to be 4 units away from 0. That's essentially what we are trying to figure out is whatever inside of it, how far away is it from 0? And we know it's 4 units away. So we have to figure out, hey, what values of x, when I subtract 3 from it, are 4 units away from 0? Because if we think back to what it means to be absolute value, whatever is inside, that has to be some amount of units away from 0. So x minus 3, the value of that, when I subtract the value of 3 from x, I have to be 4 units away from 0. So that's essentially what we're trying to talk about here. So we have to rewrite the equation as 2 cases. We know it has to be 4 units away from 0. So if I had a number line, say at 0, well, I know 4 is 4 units away from 0, but also so is negative 4. The distance is still 4 units. The distance is 4 units. So since we're 4 units away from 0, we have 2 possible cases here. We could have x minus 3, the absolute value of that, is equal to 4 when we split that up. we get case 1, x minus 3 is equal to negative 4, and x minus 3 is equal to positive 4, because we could be 4 units to the right of 0 or 4 units to the left of 0. So when we solve for x, we get that x could be equal to negative 1, and x could also be equal to 7. And if we go back to check it, if we go back and check, we have the absolute value of x minus 3 is equal to 4. Well, what is negative 1 minus 3? That's negative 4. The absolute value of negative 4 is positive 4. So that checks out. If we have x is equal to 7, well, we plug it in. 7 minus 3 is 4, and the absolute value of 4 is still 4. So we know that we're going to have those two solutions. Awesome. With that in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move forward. So some absolute value equations have two solutions, as we just went through in that example. Others have one solution or even no solutions. To decide how many solutions there are, first, again, we have to isolate the absolute value expression. Again, this is the big thing here. We have to isolate the absolute value expression. We're not isolating a variable. We're isolating the absolute value expression. So we're going to go through 3 possible situations. We're going to go through a time where we have 2 solutions, 1 solution, and no solutions, and explain why it is. So if we have the original equation, the absolute value of x plus 5 is equal to 7, well, when we simplify it, we get that the absolute value of x is equal to 2. So this has to have 2 solutions, because it could have negative 2 and positive 2, because whatever is inside that absolute value symbol, that has to be 2 units away from 0. So negative 2 is 2 units away from 0, and positive 2 is 2 units away from 0. So we get 2 solutions. And notice that the absolute value is equal to a positive number. It's equal to a positive number here. As we go down, if we look at this situation here, the original is the absolute value of x minus 5 plus 2 is equal to 2. When we isolate it, we get the absolute value of x minus 5 is equal to 0. Well, we're trying to figure out, hey, x minus 5, whatever that is, it has to be 0 units away from 0. So we can't go to the right or we can't go to the left on the number line. So it has to be equal to 0. It's 0 units away. So we set that equal to x minus 5 equals 0, and then we find that the only possible value is positive 5. And we can check this, because if we wanted to say, okay, if we have negative 5, let's plug it in and see by contradiction. Well, negative 5 minus 5 is negative 10, and the absolute value of negative 10 is 10. It's not 0. So we only get one solution here, because, again, it's equal to 0. And lastly, with this example here, we have our starting or our original equation, the absolute value of x plus 7 plus 4 is equal to 1. When we isolate, we're going to have the absolute value of x plus 7 is equal to negative 3. So what this means is x plus 7, whatever that is, that has to be negative 3 units away from 0. Well, we can't have a negative distance, and the absolute value is measuring the distance away from 0. And we can't have a negative distance. It doesn't exist. It's like if I asked you to drive 3 miles, right? You could be able to do that. If I asked you to drive negative 3 miles, you'd be like, huh? What? I can't do that. Because we can't go a negative distance. So since we have the absolute value isolated and it's equal to a negative, this is going to be a no solution, because again, it's equal to a negative. An absolute value expression can never be equal to a negative number. So with this, let's go through an example together. We're going to solve for the absolute value. So first thing we need to do is we need to isolate. So we have to get that absolute value of 2x plus 1 isolated. So we have to add 3 to both sides. And now we get the absolute value of 2x plus 1 is isolated. That's equal to negative 4. Well, it's equal to a negative number, and an absolute value can't be negative. It can't be a negative distance away. So the equation has no solution, because when we isolate that absolute value, it can't equal a negative. Awesome job. With this in mind, please work on problems 5 through 8 on the guided notes. You're doing a great job with this, folks. Please let me know if you have any questions, and I will talk to you soon. Thanks.